Hi, this is a project that we did for the CS Total 9 machine learning course in Stanford. And the goal of this project is to predict merger and acquisition target in the next month. We want to do this because we know that typically when a stock become a merger and acquisition target, and during the announcement, after the announcement, the stock price of the company that becomes the merger and acquisition target can increase a lot. So we want to profit from buying the merger and target and acquisition target before the announcement. We can also use this predicting model as a risk management tool by avoiding shorting the merger and acquisition target. And we can also understand the reason that a company could potentially become a merger and acquisition target. The features that we use for this project include 7 categories and in total 53 different type of the features. I will give a brief introduction for the 7 category. Uh, they are value, which describes the ratio between the company fundamentals and their market valuation, for example, earnings per share. The second category is the quality, described the company's earning ability, stability, and probability of repaying the debt on time. And the third category is growth, which describes the company's growth potential. And the fourth category is the sentiment, which is extracted from the news and tweets about this company using natural language processing techniques by Bloomberg. And the fifth category is the technical indicators, which describes the stock price momentum, the stock price volatility, etc. And the sixth category is from SEC Edgar filing database. This is the count of the SEC form disclosed the material information of the company required by the SEC. And the fifth category is the sector momentum. So we experimented type of the five type machine learning models. They are logistic regression, SVM linear kernel, SVM Gaussian kernel, random forest, and XGBoost. Among the five, we find the SVM with Gaussian kernel performs the best. Because we have a very imbalanced data set, so the M&A events are very rare, typically only the 0.25% of the universe. We experiment the techniques to balance out the data set to solve the imbalance data set problem. So we try out the random undersampling, oversampling, smooth clustering, and tuning the ratio between the negative and positive samples. What we found is a random undersampling technique improved the performance modestly by relatively lower computational cost, and also a ratio between the positive and negative sample equals to 0.8 achieved the best performance.